recording. I'm not going to take more. Okay, today we're talking about expressions with 4 terms and how we factorize them. So the idea is that when you have 4 different terms, often we don't have a common factor for all of them, but we can actually do this trick of pairing them. So coming up with a common factor for 2 different terms and then another 2 different terms, and this kind of helps us factorize. So let's look at some examples here. So let's start with 28a. So here, let's have a quick look at this. So basically here, it looks like this first term 3ab and this third term 3ad do have something in common. So what I would do in this case is I would actually rewrite this problem as 3ab plus 3ad plus d plus b. So all I did is I just swapped the order.
Can I say the answer?
Please don't. I know you know it, but I would like to explain it. So just give me a quick second here. Notice that 3a is here and 3a, which is here. We can actually use this as a common factor. So we could write 3a and then open the brackets, and then inside the brackets, all we will do is we'll just copy the leftovers. So what we would get from factorizing these 2 terms. So here we would get b plus d. And that's pretty much it from the first one. Then we have plus. Then notice how we've got d plus b. I think it would be a bit more convenient to just swap these 2 around and write them down as b plus d. It's the same thing as d plus b. But now let's think about, well, can we factorize this at all? And the answer is yes. I know it's going to look a bit strange, but what we could do here is we could put a 1 in front of b and d because we have no common terms here. So we can just leave that as 1 brackets b plus d. This will happen from time to time. This one is not the easiest thing to do, but often you'll find this is the only way to factorize something quickly. So here, notice now how b plus d appears here, and it also appears further down. So we can actually consider now this b plus d as a common factor. So b plus d will be now in the first pair of brackets, and we can now open another pair of brackets to put everything else, the leftovers, if you take this b plus d out in front of everything. So if we take this out and we take this b plus d out, all we are left with is this 3a plus 1. So I'm going to write it down in red here, 3a plus 1. And now using this strange method, we have now actually managed to factorize this using 2 pairs of brackets. So it's b plus d times 3a plus 1.
Sir.
Yes?
Why 3a plus 1?
Why 3a plus 1? You can think of it as b plus d times 3a is what gives us this first term, which is 3a times b plus d. And then b plus d times this 1 will give you plus 1 times b plus d. So in a way, if you like, you're thinking of what would expand to give me 3a times this pair of brackets plus 1 times this pair of brackets. And that would be, well, 3a in here plus 1 in here in the second pair of brackets. And if I were to expand the brackets out, I would get 3a times this pair of brackets here, so this term, and then plus 1 here times this pair of brackets. Yeah. So if you like to just think of it as this, I take out these brackets, the blue underlined pair of brackets here, and then I copy the 3a and the plus 1 into the second pair of brackets. So that could be a trick to help you remember this. Now, if you were to expand out the brackets, you would get the exact same thing we started with. Okay, so I'm going to move on to a second example just to see how we would do something like this.
Sir, but
Yes.
we shouldn't just add, for example, because like if you add it would be 6a to b to d.
We can't really add terms which are not like terms. Here, the a and the b.
And it would be 3a to b and then plus 3a to d.
Unfortunately, here we can't really add these because this is a different, completely different thing to this. And this
Sure,
is
I don't understand it.
what I mean is, normally if you have 3x plus x, then you can add this, you get 4x. But if you have 3xy plus 2xz, you can't really add these. These are completely different. It's like saying 3 iPhone S5 and 2 Samsung Galaxy S4. You can't really add them. You can't say this is going to be 5. What would that 5 be? Samsung Galaxy S4, iPhone S3. It's like you can't really compare the two. You can't really collect the two unless they have exactly the same letters. Even if only one letter is the same, you can't really add them together. And this would make sense if we were to replace each letter with a different number. So if you replace A with 1, B with 2, or something like that, D with 3, then you will see that you can't really put those together.
So, like, the process is, can you repeat the process?
Yes, but I will do it with a second example, and then I can come back to this if this didn't make sense.
Okay.
Like here, we could obviously add the 2x and the 5x to get 7x, but here that's not the point of this exercise. The point is we will try to put everything into brackets by separating, by taking this, let's say the first 2 terms here, and factorizing them using a common factor, and then taking the second 2 terms and factorizing them using a common factor. So, looking at the first 2 terms here, we can't add them because this is x squared and this is x. They are not like terms. They don't have the same algebraic part. So what we do is we just factorize using a common factor. Now, x squared and x have a common factor of x because this is x times x. That's what x squared means. And then the x is here. So we can take the x out as our common factor and then open the brackets to write down inside the brackets what we are left with if we take out the x. So x times what would give us x squared?
X. So x plus 2.
Exactly. So x plus 2, because x times x would give us x squared, and then x times 2 would give us 2x. Perfect. So that has been factorized now. Let's move on to the next bit, and let's move on and say that this is going to be plus. Now, what do we have in common here between 5x and 10? What is the common factor here?
5.
Well,
5 would be the common factor, exactly, because
Then it would be 5 outside the brackets and then the x plus 2.
exactly. So inside the brackets, we will have x plus 2, because 5 times x gives us 5x, and then 5 times 2 gives us 10. So now we are ready to do one more stage of factorizing. This is a bit harder, so let's focus here. What appears exactly the same from the first part and the second part? So that is before and after the plus. Well, that is this pair of brackets here, the x plus 2. So I'm going to underline it all using blue ink. So this entire thing now will work as our common factor. So what we'll do is we'll open one pair of brackets and we'll put x plus 2 in there as our common factor. And now we will open a new pair of brackets and we will put everything else in there. So we have x times x plus 2 and then plus 5 times x plus 2. Now this x plus 2 is a common factor for the entire expression because it appears here and it also appears here. So what we do in these cases when we have an entire pair of brackets, which is our common factor, then we just write it down as our first pair of brackets. Then we open a new pair of brackets, and then in there we copy everything else except the x plus 2, which we just took out. So what is everything else in this case? Well, that is this lonely x here, which is outside the bracket, so we'll just go ahead and copy that. And this plus 5 here, which is
I understand.
pair of brackets. Yes. So this would be the final answer here. This would be the factorized form of this example here. So that is pretty much the idea of what we are doing today. I just wanted to say that in some cases we have to be a little bit careful with the signs. So for example, in this example further down, what we have is if we try to factorize this in pairs, then we'll have to notice that x is the common factor of the first expression. Then we open brackets and we've got x plus 3. But then when we get to the second expression, because both are minus, then
It's positive.
exactly here minus 4 will have to be a common factor because this is minus and that's minus. And then we'll open the pair of brackets, but inside the pair of brackets, everything will change.
X and x plus 3.
Exactly. So minus 4 times x would give us minus 4x, and minus 4 times...
And then the answer would be x in brackets x plus 3, and then in another brackets x minus 4.
Exactly. Excellent. So this would be x plus 3, and then in another pair of brackets, you would have x minus 4. So this is the idea with these problems. I'll stop the recording here.